solve LEETCODE question 994, rotating oranges. I always think it's tomatoes. You're giving a M multiplex n grid where each cell can have one of three values: 0 representing an empty cell, and 1 representing a fresh orange, or 2 representing a rotten orange here. So every minute, any fresh orange that is 4 directionally adjacent, so basically you can only go up, down, left, right. These 4 directions to a rotten orange becomes rotten. Return minus minimum number of minutes that must elapse until no cell has a fresh orange. If it is impossible, then return -1. So let's take a look at it's a median LEETCODE question. Let's take a look at the example that I give here. There's one. This is the this is 2 representing a rotten orange, and when this orange is rotten, when 1 minute elapsed, and it's gonna rotten the one right next to it, its neighbor, right? And then the neighbor gonna rotten that their neighbors. Okay, so these 2 are rotten, and then after you have this, and this guy is gonna rotten this one as well, and then one more time, and then it's gonna 1 more minute, it's gonna rotten the last one. So the output is 1, 2, 3, 4. So the result is 4 minute. And if you take a look at this one, 2, 1, 1, 0, 1, 1, and 1, 0, 1, it written the orange. The explanation is it's because the orange in the bottom left corner, row 2, column 0, is never rotten, because rotating only happens 4 directional. So imagine that the left column, row 2, and column 0 is never rotten. It's not gonna able to happen. That's why it returned -1 here. And the grid 0, 2, it's 0, since there are already no fresh oranges at minute 0. So the answer is just 0 here. And there's some constraints here. And then if you look at the question was asked by Amazon 34 times in the last 6 months. Looking at this question, actually the example that they give you, you can kind of already figure that this is a breadth search problem, because you can see that even in the graph, it was doing layering by layering, right? Like this one goes to the neighbor, and then next, and then next, and then next, right? It's just layer by layer. I think the breadth search part is pretty straightforward, and what's confusing is actually you need to how do we handle the situation is the fresh oranges. I think there's multiple ways that you can handle the fresh orange situation. One way is that you can count the fresh oranges at the beginning when you go through the grid, and after that, each time when you pop the value, and then when you rotten one, and then you can just decrease the number and make sure it's the fresh ones are decreased. That's one way. The other way is that we can also use a visit set to keep track of all the fresh oranges, and to make sure that we can check the fresh oranges count properly. So I think everything else is pretty straightforward. So I'm gonna show you how to do this in code. And so I'm gonna use a visit set, and this visit set is used to track the fresh orange. And then let me define the graph here. So it will be length of the grid, and then the length of grid, and 0, right? So I defined it. And so for the Q for buffer search, which is the structure that data structure that we usually use with buffer search, and I want to use a DQ, and then I will set the fresh orange. Oh, I guess I don't need to set it because I actually have a visit set to track that. So next step, I already defined the things that I need. What I'm gonna do is I'm gonna go through every single cell. So for rows in range of rows and for C in range of calls, right? If grid are C equals 2, basically 2 is representing a rotten orange. That means it's rotten. What I'm gonna do is I'm gonna append the rotten orange to the Q here so that I can start popping this value and counting its neighbor in my buffer search. So the other thing that I wanted to do is while I'm going through the grid, right, and the grid RC, if it's equals 1, if it's a fresh orange in this case, remember that we mentioned we want to track the fresh orange in the visit set. So I wanted to add all the fresh oranges, actually their RC to the visit set to keep a track of all the fresh oranges. So the result that I want to return is the time, right? So I'm gonna set the time to 0 at the beginning. So while Q and visit exist, what I'm gonna do is that I'm gonna iterate through the for I in range of length of Q. I'm gonna iterate through different levels of the Q, and then for this Q, I'm just gonna pop RC equals to Q dot pop left. I'm gonna pop from the Q, and then basically the first value in this example, because the Q append originally it was this one, right? So after I pop this value out. While I pop this value out, what I'm gonna do is I'm gonna calculate its neighbor. So for DRDC, and I could use directions, but I could also just type it out since I'm only gonna use it once. So here is 1, right? And I'm gonna do -1, 0, and here will be 1 and 0 here. And then I'm gonna count the neighbors, calculate the neighbors, row and column. So it will be R plus DR and C plus DC, because this is the original one and I'm added all the 4 directions to calculate its neighbors, and then the roll call of the new neighbors is R plus R DR and C plus DC. So then I'm gonna do a condition check. So basically if the new row and column that we calculated in visit, if it's part of the fresh orange there, what we wanted to do is we want to remove it, right? We want to remove it so that it's basically the same thing as when you count the fresh count and then -1 here. It's same thing. It's just we're using a visit set, and then we want to remove this fresh orange from the visit set. So there's one less fresh orange there. And then also I'm gonna append the fresh orange to the row and the call, so that when I go up to iterate through the loop again, that I can count this row call's neighbor in the next iteration. So every single time when I pop one layer up, what I'm gonna do is I'm gonna plus equal 1 time. So I'm gonna plus 1 minute to the time so that I know the time, right? So in the end, what I'm gonna do is return the time value, but if the visit set is only when the visit set is empty. When the visit set is empty, meaning there's no fresh oranges anymore, and I'm gonna return the time. If there's still orange left, basically like the second example, there's still ones that are fresh orange in the visit set, then I'm gonna return -1. So in Python, it's how you handle it, and you basically said if not visit and then return time, else return -1. It's very straightforward, right? You can also rewrite it a little bit. You can say return -1 if visit, else time. It's basically essentially the same thing. I think that's the code here. Let's see. Yep, that's it. I hope this is helpful. Let me know if you have any additional questions, or if you think that this is helpful. Please like my video, subscribe to my channel, and I'll see you soon. Bye bye.